from Boston, Massachusetts, it's theCUBE, covering LiveWorx 18. Brought to you by PTC.
Welcome back to the Seaport in Boston, everybody. You're watching theCUBE, the leader in live tech coverage, and my name is Dave Vellante. We're here, this is day one of the PTC LiveWorx show, the confluence of Internet of Things, edge computing, AI, blockchain, security, a lot of innovation going on here in this new industry that's being formed out of a lot of older existing incumbent industries. Lieutenant Bruce Litchfield is here. He's the VP of Sustainment Operations at Lockheed Martin. Bruce, thanks so much for coming on theCUBE. Appreciate you coming on.
Thanks, David. How are you today?
I'm doing great, thanks. It's a good show here, a lot of excitement, a lot of really interesting demos. We see a lot of movement here, but I wonder if you could talk about your military experience and how it relates to your current role at Lockheed Martin.
Sure, so I spent 30 plus years in the military and I retired as Lieutenant General. So
well, thank you for your service, really.
It's an honor to serve, and time went by fast and really got to work with some great people. And when you have that in your blood, it's hard to walk away and not continue service. So I got a chance to work with Lockheed Martin, who delivers the products and builds the products that I grew up with in the Air Force. Most of my career was in the sustainment and keeping them flying kind of aspect of the Air Force. So now I get to work on them from a corporate perspective and continue to deliver products and capabilities and upgrade them so that tomorrow can be better than today, and that folks out in the field make sure that when the systems are needed and they have to use them, they're ready, capable, and to go to war, do whatever
so
do.
Sustainment is in your title, and it's your current role. So by sustainment, you mean it works when you need it to work. Describe that a little bit.
That's right. So, I mean, I use the simple term, keep them flying. And when you think about that, all over the world, 365 days a year, 24/7, you never know when a mission needs to take off or a soldier, sailor, airman, or marine might need a capability to save a life, change the course of a battle, or otherwise make a difference. And if a Lockheed Martin system's involved, I want to make sure it's there and ready to go, and they don't have to worry about whether it's going to be able to succeed in the mission.
So what's the role of technology in keeping systems up? I mean, in the IT world, it used to be just get 2 of everything, or 3 of everything, or 4 of everything, and just make things redundant. You know, that thinking obviously has evolved, but what tech is Lockheed Martin bringing to this problem?
So if you look over the systems, and I'll just I came from the Air Force, and so the Air Force is flying weapon systems that are 50 plus years old, along with, we are delivering now the F-35, which is the absolute latest in technology and capability. And so when I look at the evolution of technology over that time, it really is very impressive. And I really do term sustainment as a systems engineering problem. It's making sure the part is there, it's making sure the system's reliable, it's making sure the tech data, it's making sure the support equipment, anything that the maintenance person may need to get that jet airborne, got to make sure it's there at the right time, at the right place. And so if you look at the technology of how it's evolved over the year, it's much the same as our capability to go to war is from what I would consider the command and control of World War II, where you just launched the jet. In fact, we talked about it today. For one raid in World War II, it took almost 200 bombers to hit one target, dropping over almost 500,000 tons of munitions. To today, one aircraft can hit multiple targets with precision accuracy and keeping our airmen safe. So technology's evolved along with how we sustain aircraft has really evolved over that time frame.
So much more software obviously involved in aircraft today. How has the industry dealt with the increasing complexity as a result of things like software and code, but at the same time, it's clearly delivering more reliable systems and more efficient systems, as you just described.
That's right. So think about it in this way. Underpinning an inherent capability, such as the F-35, is the reliability of the system. So if I just take that one weapon system, so we have right now delivered over 300 aircraft, and they're bedded down at over 14 locations around the world. 74% of the items in that aircraft have never failed over the time that they've been out there, and including over about 100,000 hours worth of flight hours. Then, when you start looking at that, almost 94% of them meet or exceed their reliability requirements. So now we're just down to a few parts that we've got to make sure that we improve through regular upgrades that you would do under any normal conditions to make the most reliable system. Then, on top of that, you put the software embedded into the aircraft that helps the folks on the flight line know what's failed, where it's failed, and then how to troubleshoot. And so you brought technology to a point of what I would call the human interaction on the flight line.
And we talk a lot about predictive maintenance, anticipating failures. Presumably that's part of this capability. Is that, how real is that? Is it in action today? Is it sort of a future thing, or can you talk about that?
So it's very much in action today, and we have a predictive health, and what we're really trying to drive to is a condition-based maintenance airplane. In other words, if you think about going to a commercial airline, you don't want it to fly to fail. You want to make sure that whenever you show up, that it's ready to, you board it and you take off. Well, we're evolving the technology that evolves us to go to a condition-based maintenance, so we can do maintenance, on the off time when the aircraft's not needed, or in what I would call a scheduled kind of time frame. And that helps ensure that we don't just, it's mission ready whenever the pilots need it or whenever the sortie requirements call for it.
Okay, so let's talk about some of the challenges that you guys face in terms of bringing technology and sustaining this technology into whatever generation of aircraft. I think we're in 5th generation today.
That's right.
First of all, I guess, what's 5th generation and what are some of the challenges that you face?
All right, so let's start with 5th gen. So from an operational perspective, when someone says 5th gen technology, it's really taking into account what I would consider low observability, or other words, making the aircraft hard to detect. It's putting avionics sensors on there so that the pilot knows what's going on around them and is able to fuse that information to give them very exquisite information of what's happening on the battlefield, and then be able to keep those that are supporting him informed of what's happening. It's high maneuverability of the weapon system as well as speed that it goes. So there's the technology aspects of 5th gen. And then what I like to refer to is 5th gen sustainment, and that's really what the focus we are doing at Lockheed Martin. And what we want to be able to do is bring 5th gen sustainment capability to the field and drive the cost down so it's at a 4th gen or below the price of what current systems are. So get new technology, modern technology, sustain it at a very high readiness rate at a cost lower than what they currently see today. So 5th for 4th is one of the mantras that we're trying to deliver, or at least drive the cost down as low as possible. And one of the challenges that I would say is that balance between how do you have, insert capability and then keep the cost down. And so you have to do things differently. You have to evolve to a new way of looking. So we talked about condition-based maintenance, or evolving to it in a capability where you don't fly to fail. You do it when the system's down, or when you do it on a scheduled basis to do that. At the same time, you have to integrate all the capabilities together for software, to bring in analytics into the capabilities that you have, and prognostics kind of maintenance to the field. And so it's a systems engineering, a complex systems engineering problem. And really that's what makes, kind of I would call the strength of Lockheed Martin, which prides itself on being a technology company making tomorrow better than today.
Yeah, and a systems thinker.
And a systems thinker.
When you talk about these capabilities, observability, avionics capabilities, maneuverability, increased speeds, it just jumps to my head, data.
That's
right.
right.
Let's talk about the role of data and analytics. I mean, the data explosion here. How are you dealing with all that data?
So we get close to a terabyte worth of information, a day. And then how you exploit that really goes across the entirety of what I would call the sustainment ecosystem. And if you look at it, sustainment probably, we can break it down into about 11 different areas. So whether it's supply chain, whether it's managing the inventory that we have within the supply chain, whether it's in reliability, prognostics, whether it's in the maintenance, repair, and overhaul capability. So we're bringing analytics across the entire spectrum of that, and what we're out doing right now is getting best of breed capabilities so that we can piece together a holistic picture to better sustain this weapon system. So data is the key to doing that. At the end of the day, It's how do you bring that data and then bring it to what I would call the analog piece, or the human being at the flight line that still has to maintain the parts, but we want to make sure the right part is at the right place at the right time.
So the human's still the last mile. That terabyte a day, is the majority of that stored? Is it persisted, or is a lot of it kind of throwaway data?
No, I mean the great news is we capture that data, and so we have a chance to go utilize it to improve, not only what tomorrow is, but if I look at analytics for sustainment piece, I look at it in 3 pieces. One is a dashboard, all right, where are you? What's the status? Okay, that's good, that's your speedometer. Mm-hmm. Then it is, how do you do decision aids and tools, which means how do you make better decisions to affect maybe tomorrow's operation. And then there's the third part about it, which is predictive analytics. How do I make decisions today that affect me 3 to 5 years apart, and then I can make a decision today and have confidence that down the road, that's absolutely going to be the right decision.
And the first two, the status and the decision aids, I mean, those are real time or near real time.
Very much so.
Pretty much instantaneous types
right.
of things. So that's a challenge, obviously, to deal with.
It is, and then we are dealing with defense, so you got to be always cognizant of security, cybersecurity, and making sure that what you do keeps that data safe and makes sure that no one be able to tamper with it, so that you're making real-time decisions based on the known capabilities of the data and where it comes from.
Well, Bruce, thanks so much for coming on theCUBE. Hope you're enjoying the LiveWorx show, and it was really a pleasure having you.
David, thank you. It's a great show, and it's great to be here.
Our pleasure. Okay, keep it right there, everybody. We'll be back with our next guest. You're watching theCUBE live from LiveWorx in Boston. We'll be right back.